Well, the Vixen 2 is all done. In fact, I've been flying it. I've got about 5 total flight hours on it. Just doing some tuning on it, playing around with the differential rates, the CG, of course, and some rudder mix ratios as well. Just getting this plane really fine-tuned. And it flies as good or better than it looks. So I'm pretty happy with how it came out. As I mentioned earlier in the videos, this is a pretty straightforward F5J electric build, but with all electrics, there's complications about getting the power system work correctly and get all the wiring plumbed out, and also getting the CG in the correct place, because you don't want to have to add any nose weight or add tail weight either. You want to put the equipment in the right place to get the plane in the right CG range to start. So let me show you some of the specific construction details of the Vixen 2. So if you're going to be building one of these in the future, you can kind of follow my guidelines, and I'll show you, where I place my equipment, how I did the wiring, how I installed the wing servos, and all those kind of little details that are kind of specific for the Vixen 2. So let's check out those construction details. So here's the female end of the 6-pin MPX connector sunk into the wing root, and it's located between where the joiner goes and the rear locating incidence pin. You don't want to put it here because this is where the ballast tube goes. So in between these 2 points is a perfect spot for this. I did put a plywood backing plate behind here that kind of covers this area because it's so thin, the carbon's so thin here, there's not a whole lot for the glue to grip onto. So with the backing plate, it gives it a little more glue area and just strengthens that pin, because when you shove the wing together, it just wants to push the connector back out into the fuselage. So a little bit challenging to do, but not too bad. So here's a 4-pin Dean's connector. This is in the right wing root, the inside panel here. And this plugs in and powers up the aileron in the wingtip here. I always put my offset pin here forward on all my planes. This is an old habit. And so when I'm plugging these in, a couple of planes I have manual hookups for this. I always know that single pin is outside too, and I always put plus here, signal, ground. So here's a left wingtip, and this is the 4-pin female side of the 4-pin Dean's connector here. I have these free floating. The root material here, the balsa is really, really soft, and I was a little bit lazy to build out a connecting plate to make these auto connect, because I'm going to have these wingtips taped on to the root sections. 99% of the time, I'm really going to take those 2 panels apart, so I'm just going to leave these free floating here. I would definitely have to make a reinforcing piece here, because when you put these together, it really wants to push that connector back through the root material and into the hollow part of the wing. So I'm just going to leave these free floating. Works perfectly fine for now. So here's a canopy. I did a couple of mods. The first thing was to put an extra piece of spread toe with some CA over the back of the spring here, just to keep it in. It was pretty darn strong, but it just keeps it a little bit more secure and a little bit tighter. So I did that on both ends. Put some arrows on here. This canopy is pretty symmetrical, and it's easy to put it on backwards. So I just have some arrows to tell me which way to put it on. And as for color, I wanted to differentiate my plane from all the other Vixens that are going to be out there. So I used some sign material and just did a quick coating of the sign material over the canopy instead of painting it, which is hard to do with carbon. So it's pretty lightweight, and if I want to change the color, I can just peel this off and make it orange or some other color. So here's a close-up of the flap servo installed in the left wing. The frames make this super easy, and also the built-in linear drive system really makes this super easy. I think it took me about 15 minutes per servo to get these set up in the wing here. And I just used a little bit of JB weld on the frame to glue it in. No weights, because I didn't want to distort the top skin at all, and you can't tell where the servo is. And I did have to cut this push rod here. This is a pre-production plane, so this rod was a little too long to get the servo frame more square into the pocket here. So I had to cut that, make my own bend, no big deal. A little bit of a black CA keeper here, which just keeps this in place. But if I need to change the servo out, this will pop right through the horn, no problem. This is the cable for the aileron, runs to the Dean's connector on the other root here. And the nice thing about the LDS too is that it's such a short throw system that I didn't need to have to cock the servo arms back very much at all to get the required throw. I'm getting about 90 degrees of flaps, plenty of up, plenty of down. I even had to back off the volume quite a bit, and also the horn can stay pretty short here. So everything's nice and really, really tight. There's no slop in the system at all. This little block here, This is the block that ties in the servo frame to the bottom wing skin here. So everything's integrated and stiff, and there's no flex in the servo system itself. So here's the power end of the Vixen. For a firewall, I'm using the PNC Designs aluminum firewall in 30 millimeters. I have these on all my airplanes. They really strengthen up the front of the nose for contest landings, and it just makes it easier for the motor to get in and out. They're very precise, and they work really, really well. This is a GM prop set. This is a 1410 pitch folding prop with the new GM spinner as well. Now for these airplanes, we want dash speed for F5J and not necessarily, time to climb torque. So that's why with the gearbox, which puts out more RPMs at the end here, and running a 4S pack, we're getting a lot of pitch speed. So this airplane dashes really fast at full power. This thing gets up and goes very, very quickly. I'm pretty happy with the power performance, especially on a 4S pack here. So, prop, we want more, a lower ratio, so we want less diameter and more pitch. So I might even try like a 1310 or a 1311 in the future too, just to see what that does. I like the spinner design too, with the collet versus the RFM spinners, which I have on my other planes, which uses a small Allen head set screw, which are always a little scary, and you got to use Loctite on those for sure. But I like the collet here. It's easy to torque down really hard because it's a bigger head. It's easy to set the gap space between the spinner and the firewall as well. For the rubber bands here, the stock ones that came with kind of fell apart pretty quickly, but I'm using actually girls' hair bands, which are just rubber bands with like a cloth covering here, doubled up here. And that seems to work because the edge on the spinner here is really sharp and destroyed the first two rubber band setups I had pretty quickly. But that works well now. They snap back really nicely. So that's the power end. Now, as far as thrust angles of the firewall, I have mine set at 0, 0, which means the firewall is at 90 degrees to the 0 decollage angle of the wing, which is approximately this angle here. This plane tracks absolutely straight and true. Took just a little bit of trim to compensate, and that's mostly for the reflex in the wing. And it tracks right up a 45-degree line, full power, hands off, even at the aft CG I like to run at. So you don't need any side thrust. You don't need any down thrust as well. 1 or 2 degrees, no big deal. But any more than that, you're going to have to trim it out, and you're just getting trim drag. So this is the servo tray with the elevator and rudder servos glued into the tray, and the tray's been glued into the aft part of the fuselage here. It's actually pretty simple to do. I think the only challenge here is that the push rods are, we don't have any room for like a standard link for adjustment here. So you got to make sure your servos are centered up correctly, all your trims are zeroed out in the radio, because when you do your final bend here, you want to have it right so the servo is at dead top center if possible. And instead of using Z-bends, I just use a little modified L-bend, which is bent a little bit further, keeps it in, makes it easily removable. And there's absolutely no slop in this system at all. It's super, super tight. One thing I noticed when under load, elevator load, I was getting a little bit of flex in the tray and right here at the push rod. In hindsight, I probably would have put the elevator servo here and the rudder servo up front, and that would have solved that problem. But I kind of solved the flex problem by just putting a balsa block here, a little bit of carbon toe over the top, seated it together, and that tied in the tray to the rod sheath here and into the fuse. So everything is really, really tight, and there's no flex. Now the elevator install on this plane is very straightforward, but on the rudder here, a couple of quick tips. This little clevis pin here, brass, it doesn't stick out, everything's concealed. It actually sticks straight back into the balsa, which is here in the rudder, is a hard point to mount this into. Main trick is you want to find the natural fall of that wire where it comes out. I think there's already an L-bend in it, but you can put your own bend in it, put it on the clevis, kind of see where it naturally wants to fall. If it's too high and this wire has to bend upwards to get into it, it may cause some double neutral issues. If it's too low, it's going to hit down here in the bottom of the fuse. So just follow that wire flow, mount it in, just press into the rudder, mark it, drill a hole and some CA, and that's all you need to do. So let me show you my equipment layout for the nose here and talk about some CG issues that sort of came up with this plane as I was putting it together. Usually when you're putting together an electric, you want everything pushed back in the plane as far as possible because they usually come out nose heavy, so servos, batteries, everything gets pushed aft. And I was kind of taking that attitude as I built the plane. But once I did a little test, it turned out that the plane was going to be tail heavy, so everything had to go back forward as far as it could. And so I kind of changed my equipment layout a bit. And then once I kind of found out what the real flying CG is, I was able to move things back a little bit more. So initially I kind of panicked because the thing was going to be definitely tail heavy. So, but it all worked out. I have no nose weight and no tail weight, which is great. So up in the nose, obviously we have a fixed CG location for the motor and the spinner and the firewall. That's fixed. This is the 1105 in here. It's a little bit on the higher power side, which I really like, especially if we're just sport flying and so on. And that's fixed. You could go down a little bit motor size and save a little bit of weight there, but you know, I like power. Behind that's a Castle Edge Light 50 ESC. Now on my test flights, I've been getting about a 30 amp max load, about 460 watts, I think, which is quite a bit of power for a plane this light. I probably could go down to an Edge Light 30 and, you know, save a little bit of weight there, but it's kind of nice to have a buffer because, you know, at 30 amps, this thing's barely working hard, so I know it's going to last pretty much forever. I'm not going to have any burnout problems. But the ESC is one of those things you can slide around for, you know, CG purposes. But I have mine soldered right into the back of the motor here, and you know, push as far forward as possible, and it's velcroed to the side of the fuse, so we get plenty of airflow through just the spinner gaps here, and coming over the equipment in the back here. So here's the XTC60 connector, and that goes to the ESC, and then the blue object here, which you can't see very well, is a Castle. This is a 10 amp SBEC. So, and it's wired, spliced directly into the battery connector. So when I connect the battery, that voltage is dropped through the SBEC, and I have it set to 6 volts, and then it sends that power back to the receiver and powers the airplane. So, you know, if I put a 3S pack in here, 4S, just drops that voltage down, and sends it back. And I have this system in all my airplanes. It does not rely on the ESC for airplane power, so if the ESC has a failure, which is a pretty common issue, you know, it's not going to take the BEC with it and turn your plane off and not have it flyable. You may not have no motor, but at least the plane's going to be flyable with this system. I mean, you could use a backup battery system, but I've been running this a Castle SBEC in all my planes for the last 4 or 5 years, and it's been highly reliable. You know, with these smaller packs, you kind of have to watch your flight time a bit, but there's plenty of energy, even in a small 4S pack, to run the plane for quite a long time after your 30-second motor run. So that goes back there. And here's a 4S pack. I use a rubber band just to keep the balance charger, just the balance port, you know, connected to the battery so it's not flopping around. So, and I have that Velcroed in, so I don't need foam or anything, and just Velcros and stays in there. Now I can move my CG just by moving the pack fore and aft here. Sometimes I like my CG a little bit more neutrally, sometimes a little more forward, and I can slide that pack back and forward. I can also run a 3S pack in here as well. You can see here the 2.4 antennas. I run Spectrum. I initially had them back here, but as I figured out the CG, I was able to move the antennas even further forward and get them away from the wing, which will improve reception. You can see they're at 90 degrees to each other. I use heat shrink over them and CA them into the fuselage here. And the antenna wires are taped to the side here so they're out of the way. And behind the battery I have the Spectrum, the satellite receiver. And that's just Velcroed to the side here. And everything runs back. The receiver is basically back here. Here's a satellite antenna. Same thing, just going through the fuse, angled back, heat shrink on it, and glued in. So I've got a nice antenna array here because this plane is all 100% carbon. So I want a good antenna array for reception. So this is a competition airplane, so I need to be able to have a way to put in an altitude or motor limiter in line between the ESC and the receiver. And I do that. This is the line out from the ESC, and it's just a simple servo extension connector setup like this. And then I can just take whatever limiter I want. So for ALES, I can put in my Soaring Circuits CAM altitude limiter, so 30 seconds or 200 meters. And I just splice that in line here. into the other end, and then Velcro to the side of the fuse. And then for F5J, I have my Altus V4 Plus, which has the readout here. So that's going to control my motor and also record my altitude after motor shut off. So same setup, I just have that going in line here, and that allows this to control the ESC and send signals to the receiver. I can also use my little Altus Micro as well, and that goes in too. This is nice because it's really small, but you have to have the little data readout device like this to be able to read the information off of it, but it's a really cool setup. So pigtail is a must-have item for a competition F5J airplane. So here's what the front looks like ready to fly. We've got the motor ESC right behind that. We've got our Castle S-Spec putting out 6 volts to the receiver right there. Our battery here, our 4S pack, this is a 650. I can move that 4.5 to adjust the CG in small increments as well. I can also run a 3S pack if I need to. There's just enough room there. Then we have the Altus installed, hooked up to that pigtail, Velcroed to the side here. And here's our satellite for the receiver, and the receiver's riding right back here.